Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast, where I don't profess to have all the answers or be the expert on all things tech, but I am armed with a curious mind and have a few experts that I can tap into their brain and share their insights with you all too, and maybe we can all learn a thing or two together. And today's guest is an expert on the Internet of Things and the founder of Software Design Solutions. And yes, he has been on the show once before, quite some time ago though. And as an embedded software thought leader, I invited Ed back onto this tech podcast to share his experiences around the challenges and pitfalls of designing intelligence into objects. And yes, we all think the Internet of Things is incredibly cool, but what about the unique challenges within IoT in industrial control settings? And what about the role of fog computing in a world where edge nodes are becoming more and more capable? And do you really need machine learning for your IoT application? These are just a few areas that we're going to explore today, and areas that you don't hear about on the CES show floor. This isn't about the shiny. We're going to take the hood up and have a look what goes on. So come with me all the way back to Pittsburgh so we can speak with my good friend Ed once again from Software Design Solutions, who's going to share his expertise on all things IoT. Well, a massive warm welcome back to the show, Ed. But for anyone that has missed our previous conversations, can you just remind the listeners with a little bit about who you are and what you do?
Oh, thanks for having me, Neil. So my name's Ed Kuzemchak. I'm founder and CTO of Software Design Solutions here in sunny Pittsburgh, Pennsylvania. And we're an embedded system and IoT application consulting house. So we build applications in IoT space, embedded system space. We do security work. And, my background is about 30 years in embedded system software. Founded Software Design Solutions 16 years ago, and 3 years ago, we joined Software Design Solutions together with another company, Applied Visions, in Long Island, New York. And that company focuses on cloud infrastructure and mobile applications and a lot of big cloud applications. And SDS here in Pittsburgh, we focus on embedded systems. So the two of those companies together really makes for a nice combination to do IoT systems.
Now, Ed, you are widely regarded as an expert on the Internet of Things and also the founder of Software Design Solutions. But like I said a few moments ago, 300 interviews have passed since our last chat. So could you just possibly remind the listeners of the kind of problems that you enjoy solving for businesses with technology?
Sure. So the domains that we operate in are medical systems, industrial control, transportation, oil and gas. And in those systems, I guess if you tried to find a common theme throughout, it really is a lot of folks taking an existing system that they have, and as they build the next version, they want to add some intelligence. And in an industrial system, it might mean they want to add some intelligence to their industrial manufacturing system without changing out the equipment. Because the last thing they want to do is replace this, metal stamping machine that is 25 years old or 40 years old, because it's doing its job just fine. But, like every mechanical piece of equipment, it eventually breaks down, and they'd like to add some sensors and some predictive analytics and some preventative maintenance so that they can, have a better feel for when they need to schedule even something like preventative maintenance. So those are the kinds of systems that we work on. It's very broad ranging. Many of, one of the things I like to say about the engineers here is they're not specifically experts in any specific domain. What they are is very high quality embedded system designers, very good thinkers in terms of getting together with a customer and saying, what are you trying to solve? Let me talk to your domain expert and learn what I can from them and keep them involved in the process.
So, as an expert in this area, can you tell me more about how the convergence of low-cost networking combined with the power-efficient, highly capable edge nodes are actually changing the IoT landscape as we know it? And the reason I say that is because I keep reading about it, but I've got a feeling you can explain it in a language that everyone can understand.
Sure. So when you hear about cellular connectivity, today, what you think of, what most people think of because they're bombarded by the advertisements is 5G. And, it's important. 5G is going to be an important improvement for one use case, one type of use case, which is the high bandwidth, high data use. I need to get a lot of data somewhere fast. And that's great for, something like a connected car or something like that needs to move a lot of data. But most of what we deal with are small sensors. They're not sending a ton of data, and we don't need 5G. What we need is a more cost-effective, cellular networking capability. And at the same time as 5G is being rolled out, kind of in the shadows, without nearly as much fanfare, is technologies like NB-IoT, narrowband IoT, or LTE Cat M1. And so this is specifically Cat M1 is taking the existing LTE infrastructure and giving you a light version of that. In other words, here's a networking technology that isn't enough bandwidth to say do a voice phone call, and certainly not enough bandwidth to watch your Netflix movie on the train. But we don't need that. We need enough. We need enough bandwidth to send a few temperature measurements, a couple times a minute, at most. And so with that, we also don't have to pay $50 a month for it, like your cell phone bill. And so that's going to be an important enabler for IoT systems. Something like NB-IoT may cost, we have plans in place today with providers that are on the order of $6 a year for a device. And so now you can start to think about, what can I do with a device that goes directly to the cloud and only costs me $6 a year in data? I mean, that's a much more important thing than having to say, oh, I got to put up a $50 a month for this data plan. How can I make that work in my budget?
I'm also hearing about the emergence of unique challenges of the Internet of Things in the industrial control settings. That's a bit of a mouthful, but is that something that you can expand on based on the conversations you've been having with businesses?
Yeah, so I think that in industrial, there are some very, you said it, unique challenges. I mean, one of the things is something I already alluded to, which is industrial control usually doesn't replace equipment nearly as often as consumer equipment or even other industries. When you have industrial control equipment in place, it may be in place for 20 or 30 years. And so it's much more important to be able to retrofit existing equipment with new sensors to add capability than do a wholesale replacement of equipment, which requires a large capital outlay, downtime to do the installation. And so if we can talk about, adding a sensor during routine maintenance, instead of taking the system down and spending $1 million to replace the big large metal stamper just so that we can add a vibration sensor. I think that's one very important thing. The other unique challenge is the environment that these sensors have to live in is very harsh. And so you may have, an environment that is not very conducive to electronics, I would call it. And so you may have things getting wet, things being very hot or very cold. You may have a lot of vibration going on. You may be trying to get a wireless signal out in something like a large metal building or even a refinery with all kinds of catwalks and metal pipes and everything else. And so the best case scenarios of wireless technologies traveling 500 yards or half a mile or something like that, we have to temper that to understand, okay, that's great, that's over open air on a nice warm sunny day, what happens when it's pouring down rain and we're inside a metal building and also right beside a giant motor that's making all kind of electrical noise. And so those kinds of things all have to be taken into account.
Another topic that I'm excited to chat with you about today is the increasing role of fog computing, especially in a world where edge nodes are becoming more and more capable. But do you have any insights that you can share around that too?
Sure. I mean, it's a little bit related to what I mentioned. Is that these edge nodes? There's a lot of discussion in IoT that the edge is where computing is going to happen, and that's great if what you think about being the edge is an entire connected car. You have a 250 or 400 horsepower engine that can drive all kinds of electrical power. You may have a few kilowatt battery in an electrical car, and you've got all the compute power that you want in terms of being able to stack it in. If you consider the connected car an edge node, great place for edge compute. But if you think about a flow sensor on a meter in the middle of Canada somewhere, and you need a battery, you're going to have a battery there and it has to last 5 years, because how many times do you really want to trek down this pipeline to change the battery? You really can't do a whole lot of compute there. And that's where the idea of fog compute comes in. You make the edge nodes, I won't call it dumb, but you make them unsophisticated, and they just send their data, and they may do some simple filtering. But you're not likely to do things like run machine learning out on that edge node. You're more likely to send the data up to the next level, which is the gateway, and that's where you do fog computing. Now, why not send it all the way to the cloud? Well, you may not have cloud connectivity, but every other day or something like that with this system, because you may not be able to spend the power or spend the data bandwidth to do that cloud connection. So let's do the compute at a gateway, which may be at, say, a substation on this pipeline, and it would have electrical power there, AC power, because they plumbed it into the substation. They don't run it all the way along the line. And so you have the opportunity here. You have this what we like to call a sweet spot, where you have electrical power, you have enough compute capability, you can put an industrial PC there, but you're also close enough to the data that you can get a few readings. You can get one from this meter and one from that meter and one from the meter down the line, and you can start to see if there's a leak in the pipeline just by comparing the flow rates. So that's a lot of I think that's a lot of what we're seeing in some specific domains, is the ability to do fog compute.
And anyone that follows tech news online are going to feel like they're bombarded with constant news stories about machine learning and AI, especially where IoT is concerned. But I'm curious, just to bust any myths out there, do businesses need machine learning for their IoT applications?
I think that 2019, there was just an uprising of folks saying we got to go do machine learning in our application, in our industry. Everyone's doing it. I just came back from a trade show and they're doing it. I think that it is a good data analysis tool, but it is a tool. And so you have to compare it to the use case that you're trying to achieve to see if it's what you need. There are some instances where customers have come to us and wanted to do machine learning, and we talk them out of it and say, what you really need is a heuristic here, a good heuristic, because you can describe your domain expert has described your problem to a degree that it can be coded into a heuristic. There are other times where specifically if the customer has a pretty good store of data that they've already collected for other uses or other means, and they can provide that to us. This is where we can look at it and say, here's where you can maybe gather some new insights, even that neither of us are potentially thinking about, by applying machine learning to this data. And so I think that it has to be approached with care. I mean, it's not a panacea. It's not a one-size-fits-all solution. given the choice between a machine learning application and a heuristical application that performs roughly the same, we'll take the heuristical application every day because it's easier to build, it's less compute power to run, and it's easier to explain how it came to the answer that it came to. But there are plenty of opportunities where machine learning is the best choice. But you've got to have a lot of data.
And if we look towards the future, what is it that excites you about these technological advancements? Because I've got a feeling it's not going to be 5G. So is it something else?
To me, I think it's going to be a combination of battery technology and energy harvesting. A lot of the systems that we build are low power devices, and so they need to run on they run on a battery. And so battery technologies have really just not gotten to where they need to be, and they've not grown as fast as many of the other technologies, silicon technologies, and even software techniques. And so an improvement in battery technologies I'm really looking forward to. And while that is on its way, the rise of energy harvesting, whether it is wireless energy harvesting, or motion, or light, or temperature. There are a lot of folks doing a lot of neat things in energy harvesting, and we follow that very closely.
So as all these technologies begin to converge, how do you see new trends and new opportunities arising as a result?
Yeah, I think that each of these technologies, as they progress, they tend to enable other things to happen, which then may drive the involvement of other technologies. Like, for example, low cost networking like NB-IoT has driven the adoption of, well, let's just put a lot more sensors out there. But a lot more sensors out there now, they really have to be low power. And we've gotten a lot of great low power designs out of the hardware manufacturers, but now we're still consuming power. And so we have to start thinking about energy harvesting, for example, and mesh networking, because maybe these devices don't have enough reach to reach the gateway, but they can reach their neighbor. So I think there's a lot of opportunities in low power edge nodes. I guess is a common theme of what we look at as a technology that is a convergence of several other things.
And as for you guys at Software Design Solutions, what's your primary focus going to be this year? I appreciate you probably can't share too much, but is there anything you can share about the road ahead?
Yeah, I mean, we are doing a number of systems that are in prototype stage that have to do with low power, energy efficient sensing. As a company, we're focused on asset tracking. This really came about because in 2018, we built 4 different asset trackers for 4 different companies. And I said, what? I cannot believe there's not one out there that people could just buy. And there wasn't, because it didn't meet the specific needs of these 4 individual companies. And so what we saw was there's opportunity here for SDS to use our combined expertise in low power sensor development and cloud application development to build an asset tracking technology that is customizable for many different use cases. And so you'll be seeing more of that as the year goes on.
Now, we have covered a lot of ground today. We've featured all the tech buzzwords and a few more too. So can you just remind the listeners of where they can find you online, and also contact your team if they are left with any questions?
So you can find us at softwaredesignsolutions.com. And there you can see some white papers and fancy podcasts like this. This podcast will be linked up there soon. And you can see a lot of what we do, as well as find a way to contact us and have us look at your system. We love to talk with people about what they're working on. We're not a classic consulting agency that, we'll come in, we'll turn the meter on when we walk in the door, and let's have a conversation. We'll give you a bill at the end. That's not how we work. We like to talk with people about fancy new technology, and then decide if there's anything there that we can help with and go from there.
Well, Ed, one of the reasons I love getting you on here is because we always talk about, yes, the big tech trends and those buzzwords, IoT, AI, 5G, etc. But we always scratch beneath the surface and look beyond those shiny buzzwords and the shiny new tech that we see on the show floors of CES, and actually look under the hood to understand how this technology works. Because I think only then can we understand how we can create new solutions and also understand the tech's limitations too. So it's been an absolute pleasure as always, and thanks so much for taking the time out of your day to come on here, share your insights, not only with me, but everyone listening all over the world. So thanks again, Ed.
Thank you for having me, Neil.
When talking about the convergence of low-cost networking and power-efficient, highly capable edge nodes and how they're changing the IoT landscape and fog computing in a world where edge nodes are becoming more and more capable, I must admit I felt like doing my best Keanu Reeves impression in Bill and Ted's Excellent Adventure and go, whoa. But I remained on my best behaviour throughout. But I just love getting Ed on this podcast, because he doesn't just talk about the shiny side of IoT. He dives into the real challenges and the real solutions to those challenges too. And isn't it great to every now and again have a look under the hood and look behind the smoke and mirrors and learn how this stuff really works? And if there's anything you want to add to today's conversation, if you've got expertise and insights in your field, please email me techblogwriter@outlook.com, tweet me at Neil C. Hughes, or visit my website, techblogwriter.co.uk. So I hope you enjoyed today's episode as much as I did and delving a little bit deeper into the world of the Internet of Things and not just talking about 5G. And if you enjoyed it, why not join me again tomorrow for another episode? So a big thank you for listening, and until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.